Welcome to a tutorial on the Theory of Mind Inventory-2. This tutorial lasts less than 40 minutes and is designed to give you an overview of the purpose, development, content, administration, scoring, and interpretation of the Theory of Mind Inventory-2. The Theory of Mind Inventory-2 was developed and validated by Tiffany Hutchins, Patricia Prelock, and Laura Bonazinga-Bouye, and was copyrighted in 2016. Today's presentation is delivered by Jennifer Campbell, Maggie McCarthy, Kaylin Legary, and Samantha Taylor. The Theory of Mind Inventory-2, also known as the ToMI-2, can be purchased and downloaded at theoryofmindinventory.com. Along with the ToMI-2, you also get the technical manual for the ToMI-2, the ToMI-2 Guide to Clinical Decision-Making, as well as access to HIPAA-compliant web-based ToMI-2 administration, scoring, and report generation. With one purchase package, you also have the option to download the ToMI-2 sister measure known as the Theory of Mind Task Battery. The Theory of Mind Task Battery was co-developed with the ToMI-2, and it is a direct measure of child theory of mind performance. You can learn more about the Theory of Mind Task Battery by visiting theoryofmindinventory.com. Finally, ToMI-2 users will eventually have access to the Theory of Mind Atlas. This is a reference manual that is currently in development and which will be made available for download from theoryofmindinventory.com. This manual gives a user-friendly primer designed to support professionals' understanding of theory of mind and to give professionals materials that they can use to communicate about theory of mind with caregivers and other professionals. The Theory of Mind Atlas describes each item in the ToMI-2 in detail. It describes the theory of mind domain tapped by each item, when it emerges in typical development, related cognitive achievements, and what is known about how this domain functions in autism spectrum disorder. The ToMI-2 is intended to measure broad theory of mind functioning. The ToMI-2 was developed in response to the need for a content-valid measure of theory of mind, as traditional measures only assess a very narrow range of theory of mind domains. The ToMI-2 is a well-validated caregiver informant measure that can be used to reliably and accurately assess children's theory of mind strengths and challenges. Since it is a caregiver informant measure, the ToMI-2 does not suffer from test practice effects, which makes it useful as a pre- and post-test assessment. The ToMI-2 can also be used in the context of research, and there are many examples from the literature demonstrating its utility when employed as an independent variable, a dependent variable, and as a criterion for matching groups. It can also be used in clinical work. It can be used to assess the effects of a social skills or social cognition curricula, to monitor treatment progress, and perhaps one of its greatest strengths, it can be used as a tool to identify developmentally appropriate treatment targets. Of course, another important potential use of the ToMI-2 is that it can help facilitate a conversation with caregivers to further explore the child's strengths and challenges and to determine families' priorities for intervention. The ToMI-2 can also be used as a part of a larger assessment battery to identify children at risk for poor theory of mind outcomes. For children with autism spectrum disorder, the sensitivity and specificity data are impressive, around 90% for each, and this result has been independently replicated. Indeed, we find that the ToMI-2 may be particularly useful in identification of autism spectrum disorder among those individuals who present with the most advanced cognitive and language skills and who may be missed when using existing measures of autism severity and social cognition. It is important to note, however, that the ToMI-2 is not intended as a measure of autistic symptoms. It is intended as a measure of theory of mind, and theory of mind impairments are seen in a range of psychiatric and developmental disorders other than autism spectrum disorder. For example, theory of mind impairments have been documented for conditions such as sensory loss, for example, deaf and hard of hearing and blindness, attention deficit hyperactivity disorder, fetal alcohol syndrome, Fragile X syndrome, specific language impairment, learning disability, intellectual disability, and schizophrenia. What this means is that to the degree that there are broad commonalities in theory of mind impairments across clinical conditions, the ToMI-2 is not appropriate as a tool for differential diagnosis. On the other hand, some research suggests the presence of syndrome-specific theory of mind deficiencies and proficiencies. Because the ToMI-2 taps a wide range of theory of mind understandings and skill sets, there is a potential for the use of the ToMI-2 for differential diagnosis in the future as more information accrues to inform the questions as to whether there are unique theory of mind profiles associated with specific clinical populations. The ToMI-2 was developed on a normative sample of children ages 2 to 13 years. As will be described in more detail a little later on, the ToMI-2 yields 3 empirically derived subscales that represent a developmental progression of theory of mind. For the youngest children in our sample, scores for advanced items are not meaningful because those theory of mind knowledge and skill areas are not expected to be emerging or established. For this reason, we recommend that for children ages 2 to 3, professionals administer the Theory of Mind Inventory-2 toddler screen, which is made up of early subscale items only. Administering only these items has the advantage of saving time during administration. It also encourages professionals to focus on those areas that will yield the best information regarding risk. For the ToMI-2, ceiling effects are observed for typically developing samples around age 13, but no ceiling effects are observed for autism spectrum disorder samples, even among the oldest and highly verbal individuals. Thus, the ToMI-2 can be appropriately used for adolescents and adults, a proposition that has been empirically confirmed by Lerner et al., 2011. When using the ToMI-2 for older individuals at risk for poor theory of mind development, scores are automatically compared to the oldest children in the typically developing sample, that is 13 years, during computer-based scoring and report generation. ToMI-2 results are both interesting and informative when scores for individuals older than 13 years fall in the low average or below average range. This is because ceiling effects occur for typically developing children around age 13, and so the score for a person over 13 is expected to be high and near or at a ceiling score. So when it is not, this can yield useful clinical information and can be interpreted to reflect a theory of mind impairment. A downloadable self-report version of the Theory of Mind Inventory-2 is also available for use. As previously described, results of the Theory of Mind Inventory-2 can be appropriately interpreted when used with individuals who are older than the oldest persons in the normative sample. Using similar logic, the results of the self-report measure can be interesting and meaningful when completed by adolescents and adults who have normal or near normal language and reading skills. With regard to reading level, and based on a formal evaluation of the reading level of the Theory of Mind Inventory, we recommend a minimum reading level at the 9th grade level. Of course, it is possible that some persons will have diminished introspection abilities, which may masquerade as high scores on a self-report version of the ToMI-2. For this reason, high self-report scores for persons who are at risk for poor theory of mind development should be interpreted with great caution. On the other hand, when self-report scores for some, many, or all items fall in the low average or below average range, professionals can have greater confidence that the individual offered a more critical evaluation of his or her theory of mind strengths and challenges. In short, this can yield useful clinical information and can be interpreted to reflect a theory of mind impairment. In its present form, the ToMI-2 consists of 60 items designed to tap a wide range of social cognitive understandings. Each item takes the form of a statement. For example, my child understands whether someone hurts another on purpose or by accident. Items from the earlier version of the ToMI were relegated to subscales on the basis of principal components analysis. These are the early, basic, and advanced subscales. An additional 18 items were added to these subscales on both empirical and theoretical basis. After finalizing the content of the early, basic, and advanced subscales, the ToMI-2 was also scrutinized for the presence of additional subscales. 3 additional subscales were identified on theoretical basis where items appeared to belong to a particular theory of mind content domain while also spanning early, basic, and advanced levels of theory of mind. These subscales are the emotion recognition, mental state term comprehension, and pragmatics subscales. The early, basic, and advanced subscales represent a developmental progression of theory of mind. The early subscale taps theory of mind abilities that typically emerge in late infancy and toddlerhood. Examples include gaze monitoring, joint attention, and social referencing. The basic subscale taps theory of mind abilities that typically emerge in the preschool years. Examples include understanding false beliefs, the mental-physical distinction, for example, understanding that imagining the idea of a dog is different from an actual dog, and the ability to deceive. The advanced subscale taps theory of mind abilities that typically emerge in late childhood but continue into adolescence. Examples include second-order false belief, metalinguistic aspects of language, and complex social judgment. As previously stated, the three rationally derived subscales are the emotion recognition, mental state term comprehension, and pragmatics subscales. The emotion recognition subscale is intended to tap the ability to recognize a variety of emotions. Examples include recognition of basic and complex emotions and ability to discriminate emotions. The mental state term comprehension subscale is intended to tap understanding of mental state terms. Examples include understanding the terms want and think and know, and speech acts like promise. The pragmatic subscale is intended to tap understanding of pragmatic and mentalistic aspects of language. Examples include the understanding of sarcasm, play on words, and audience adaptation. The experimental version of the measure, that is, the Perceptions of Children's Theory of Mind measure, experimental version, and the subsequent version of this tool, that is, the Theory of Mind Inventory, and now the Theory of Mind Inventory-2, have all been rigorously evaluated for multiple forms of reliability and validity. The measure has been found to demonstrate excellent test-retest reliability for a typically developing sample and an autism spectrum disorder sample for both long and short intervals. The measure has demonstrated excellent internal consistency, suggesting that the measure taps a unitary construct that is theory of mind. The measure has excellent content validity and taps a wide range of theory of mind competencies across levels of development. It has been scrutinized for multiple forms of criterion-related validity, and it correlates highly with measures of social adaptive functioning, language, autism severity, and direct child performance measures of theory of mind. It also has excellent contrasting groups validity, and it distinguishes younger from older children and children with and without developmental delays. 4 articles published in the Journal of Autism and Developmental Disabilities are available at theoryofmindinventory.com. They describe the rigorous psychometric evaluation of the Theory of Mind Inventory, and more specific statistics are also offered in the technical manual for the Theory of Mind Inventory-2. The ToMI-2 should be completed in a quiet, well-lit, and comfortable environment. Caregivers should be then asked to read the instructions in their entirety and to pay close attention to the examples of correct and incorrect response strategies. The ToMI-2 takes approximately 10 minutes to complete. The ToMI-2 was developed for parents who are either native English speakers or bilingual caregivers who are fluent in English. The ToMI-2 should not be administered to caregivers who are not fluent English speakers. However, some carefully vetted Theory of Mind Inventory and Theory of Mind Inventory-2 translations, for example in French, Italian, German, Spanish, and others, have been developed by other researchers, and many have been evaluated for reliability and validity and have supporting normative data. Contact information for the authors of all Theory of Mind Inventory translations is available at theoryofmindinventory.com under the translations link of the website. Test administrators should avoid answering questions about the content of the test. In our experience, questions rarely arise, but when they do, variability in administrators' responses has the potential to introduce error. For this reason, we recommend that respondents be directed to interpret the question the best you can and try to give your most general answer using everything you know about this child. ToMI-2 users have the option to send an invitation to a caregiver who can complete the ToMI entirely online. To access this feature, users visit theoryofmindinventory.com, link to the dashboard, and click on the option that reads Send or Score a ToMI. Users are then taken to a web page where they enter their name and email, as well as the caregiver's email and a unique client identifier. This web-based administration feature is entirely HIPAA compliant. At no time are personal identifiers, for example, electronic identifiers such as email address and URLs linked to administration, scoring, or report generation. The electronic version was carefully designed to ensure that it is identical in content, page layout, and method of responding to the paper version of the tool. As such, differences in scores due to method of administration are assumed to be negligible. Of course, users are not limited to electronic administration and scoring, and have the option of printing paper measures, hand scoring them, and entering the scores online to generate a report. Each of the 60 items comprising the ToMI-2 can be scored using the ruler that appears on the final page of the measure. The ToMI-2 utilizes a continuum and hash mark response arrangement. Whether the respondent's hash mark is slanted or perpendicular in relation to the continuum is irrelevant, and in both cases the item is scored by measuring the precise point of intersection. To enhance precision, rounding full integers is discouraged and each item should be scored to 1 decimal place. For example, a score of 16.2 is preferable to a rounded score of 16. Hand scoring using the ruler takes approximately 5 minutes. Scores on the ToMI-2 range from 0 to 20, with higher values indicating higher caregiver confidence that the child possesses a theory of mind knowledge or skill set. This is true at all levels of analysis, including scores at the item level, subscale level, and at the overall or composite score level. The ToMI-2 yields raw scores, percentile ranks, and standard scores. For the composite or total score, the standard score has a mean of 100 and standard deviation of 15. By contrast, the subscale standard scores are T-scores. They have a mean of 50 and a standard deviation of 10. Only raw and percentile rank data are available at the item level. Recall that the materials that accompany the ToMI-2 include the ToMI-2 Guide to Clinical Decision Making. The purpose of this document is to introduce the descriptive developmental approach to treatment planning, which will be described in more detail shortly. This guide also includes several case studies that illustrate how ToMI-2 results can be applied to treatment planning. There is also a sample write-up of a report as well as a template for an interview that can be used with caregivers to further explore the nature of the child's theory of mind strengths and challenges and to help determine the parent's priorities for treatment planning. Recall that the ToMI-2 can also be used to identify specific challenge areas that can be targeted for intervention, but identifying challenge areas is only the first step in treatment target selection. A critical second step is to determine whether and which treatment targets are also developmentally appropriate, and it is surprising how often this is overlooked in interventions to support theory of mind. One significant advantage of the ToMI-2, which is a developmentally sequenced broadband measure of theory of mind, is that not only can it identify theory of mind strength and challenge areas, but it generates an analysis for each individual that is rooted in an empirically driven understanding of theory of mind development. A descriptive developmental approach is one in which the typical development sequence of skills in a particular domain is detailed. The developmental sequence is then compared to the results of a comprehensive assessment for a given individual to determine the earliest skills that are in need of support. This is important because early skills are often foundational to later developing skills, and they are more readily supported because of their status as early emerging skills. This descriptive developmental approach is routine in other clinical sciences, including speech-language pathology. For example, when determining which speech sound disorders or morphological forms to target first, and has been found effective even when the developmental pathways and mechanisms that are operating in typical and disordered development are known to be different. This approach is also considered best practice because it is designed to scaffold learning in the zone of proximal development, or ZPD. Vygotsky described the zone of proximal development as the distance between the actual developmental level as determined by independent problem solving and the level of potential development as determined through problem solving under adult guidance or in collaboration with more capable peers. Indeed, instructors or clinicians who have over or underestimated the developmental level of a student or client will be well aware of the benefits of working in the zone to not only advance learning, but also to decrease frustration and motivate engagement. Using a descriptive developmental approach, the ToMI-2 can also support clinicians' understanding of theory of mind progression and identification of treatment priorities to facilitate immediate and long-term goal setting. In order for clinicians to identify the most developmentally appropriate treatment targets, they will need to have a firm understanding of the output generated by the Theory of Mind Inventory-2. The ToMI-2 report generator provides all raw and norm reference scores in a variety of ways. When reading the output, it is useful to remember that all the subscales are color-coded. As can be seen in this example, the early subscale items appear in light blue, basic subscale items appear in medium blue, and advanced subscale items appear in dark blue. Further, the emotion recognition subscale items appear in green, mental state term comprehension subscale items appear in orange, and pragmatic subscale items appear in yellow. When reading the output, it is also useful to understand that bar graphs, like the one shown here, are given for raw score data, whereas data for norm reference scores, standard scores, and percentile ranks are presented via line graphs like the one shown in the next slide. In this graph, the item number appears along the horizontal axis and the percentile rank appears along the vertical axis. The specific percentile rank is shown in the green line, and a hovering cursor, or through the use of a touchscreen, users can view the item content of each item. Raw and percentile data at the item level are also available in table format. Asterisks in these tables indicate the median percentile within a range of percentiles that are associated with the raw score for that item. This is common when raw scores approach the ceiling, that is 20, and when high scores are frequent in the normative sample. One particularly useful figure for clinical decision-making is the figure for the intra-theory of mind cognitive profile analysis. This figure provides a visual representation of subscale standard scores. The traditional range for the average, plus or minus 1 standard deviation, is indicated in yellow on this graph. One strategy to treatment planning is to consider the child's subscale, percent or standard scores to establish areas of general intervention focus at the early, basic, or advanced levels of theory of mind, or in the areas of emotion recognition, mental state term comprehension, or pragmatics. Inspection of the intra-theory of mind cognitive profile line graph in the ToMI-2 output will be particularly helpful in this regard. Of course, clinicians can also use percentile data to look within the subscales at the item level percentile scores to identify specific areas of strength or weakness to guide treatment planning. Inspection of all other line graphs, recall it is the line graphs that present the data for percentiles at the item level, will be helpful in this regard. A common approach to treatment planning makes use of normative score information like those data just described. When using normative data only, we imagine that clinicians will find it useful to consider scores at all levels, item, subscale, and composite, to inform whether treatment planning is most appropriately conducted to target general or specific theory of mind areas, or both. It is important to reiterate our commitment to a descriptive developmental approach to intervention. As such, we recommend that clinicians first focus their attention on the early, basic, and advanced subscales to identify what will likely be the most developmentally appropriate targets of intervention. When more than one subscale or item indicates functioning in the clinical range, intervention should begin with those areas that are comparatively early emerging in typical development. Scrutiny of subscale standard scores and percentiles, that is norm reference data, can also be combined with scrutiny of raw scores to inform what are likely to be developmentally appropriate theory of mind targets at the item level. Recall that raw score data reflect the degree of caregiver confidence that the child possesses a particular theory of mind competency. Consider this item that is designed to assess pretense in the case of two 10-year-old boys. One boy, Sanjay, has a caregiver who gives a score of 0, which reflects that the ability to understand pretense is definitely not present. The other boy, Jacob, has a caregiver who gives a score of 15, which reflects that the ability to understand pretense is probably present. Because pretense emerges early in typical development, and because the vast majority of caregivers of even very young, typically developing children in the normative sample indicated scores near the ceiling, both Sanjay's and Jacob's scores will fall at the first percentile. Nevertheless, there is a profound difference in the caregiver's perceptions of the likelihood of child competency in this area. For the caregiver who reports definitely not, competence is not readily apparent, is not actualized, or exists primarily as a potential. Dissimilarly, the caregiver who reports probably may be signaling that the competence, even if inconsistent or incomplete, is somewhat evident. For these reasons, considering both normative and raw scores provides additional information that can be crucial in clinical decision-making. The Table for Treatment Planning is a unique and powerful tool for identifying developmentally appropriate theory of mind targets of intervention. The 3x3 table cross-indexes raw score and normative score information. This arrangement allows for the scrutiny of strength and challenge areas in light of caregivers' confidence in the child's competency in a particular area. A skeletal version of the table without any results is shown here. The 3x3 table represents raw score data at 3 levels: not developed, indicated by a raw score between 0 and 7, undecided, indicated by a raw score between 7 and 13, and developed, indicated by a raw score between 13 and 20. Cross-references this information with normative score information at 3 levels. If the score is 1 standard deviation or greater above the mean, the score is considered high for the age of the child. It is considered average if the score falls within 1 standard deviation for the child's age, or low if it is at or below 1 standard deviation below the mean. The table yields 9 cells. One of each item on the ToMI-2 is assigned on the basis of the child's score. The upper left cell can be disregarded. Raw scores less than 7 will never be 1 standard deviation above the mean. The next 2 cells to the right, however, are considered strength areas. Here the child's raw score may be high or mid-range, but in either case the standard score for that item is 1 standard deviation above the mean. These are notable strength areas, and while strength areas should be capitalized on to support new treatment targets, these areas probably should not be considered as viable treatment targets themselves, since the indication is that the child's development in these theory of mind areas is not only on track, but may be superior. Raw scores for items that appear in the second row may be high or low, but in each case, the normative scores are typical for the child's age. For this reason, items in the second row are also considered areas of strength for individuals at risk for poor theory of mind development. The third row is where the relative deficit areas of functioning can be located. More specific guidance on how to navigate the third row to identify treatment targets is given shortly. Here is an example of actual output from the ToMI-2 report generator. Only the first 2 rows of the table are shown here for reasons of limited space. In our experience, few items, whether for neurotypical or clinical populations, are typically relegated to the 3 cells in the top row. Thus, rarely are theory of mind skills identified that are superior when compared to the normative sample. Of course, they do sometimes occur, and this makes sense in light of the significant heterogeneity that has been documented in the social cognitive functioning of individuals with autism spectrum disorder. Again, these areas should be considered areas of strength. Following inspection of the top row in the table for treatment planning, clinicians should examine the middle row to identify theory of mind areas that appear to be present and that are expected in light of the child's chronological age. Recall that the output from the ToMI-2 report generator is color-coded by subscale. The early subscale items appear in light blue, the basic subscale items appear in medium blue, and the advanced subscale items appear in dark blue. In summary, items appearing anywhere in the first 2 rows could be considered a theory of mind strength, and so recognizing these areas is central to clinical decision-making when the goal is to build on existing theory of mind knowledge so as to scaffold the child to a higher level of theory of mind development. After considering theory of mind strength areas that appear in the first 2 rows, clinicians should consider the apparent areas of deficit. Recall, these appear in the third and final row of the table for treatment planning. An example of data output from the table is given here. Again, for reasons of limited space, only the final row is shown. One general strategy that may be helpful to clinicians who are beginning to navigate this table is to adhere to the maxims of right to left and light to dark. From a developmental standpoint, items in the right hand, that is developed column, are most likely to be responsive to treatment, and they might even be relatively firmly established. For items in this cell, the caregiver has indicated that the theory of mind skill is probably, but not definitely, present. This suggests that these areas could be promising targets of intervention if intervention is deemed necessary or desirable. Clinicians are encouraged to consider which areas in this cell are important to advance or shore up, and those that represent early emerging skills are likely to have the greatest developmental significance. Thus, the items in light blue, that is the early subscale items, may be particularly apt choices. Items from the basic subscale, in medium blue, should also be considered. Next, we recommend that clinicians consider items in the middle, that is, undecided column. For these items, the caregiver indicates indecision regarding whether a theory of mind skill is present, which may signal that the skill is emerging or inconsistently applied. From a developmental standpoint, there is a potential that training in this area will provide opportunities for meaningful growth. Finally, clinicians should consider items in the left hand, that is not developed column. However, caution is warranted. Caregiver confidence in the presence of this theory of mind competency is low or very low, and clinicians should consider whether these aspects of theory of mind are developmentally appropriate targets for intervention. Advanced skills, which are commonly found in this cell, may be unlikely to benefit from intervention until more foundational skills are established. The following case example, using real data from KF, a 15-year-old boy, is now presented to illustrate how treatment targets were selected using the ToMI-2. KF enjoys video games, American history, science, and sports, and his academic strengths and personal interests include reading, writing, and drawing. The results of several standardized tests place KF in the clinical range. Despite being highly verbal, scores for receptive vocabulary, expressive vocabulary, and nonverbal IQ all placed him between the 1st and 9th percentile. A low composite ToMI-2 standard score also placed him at the 1st percentile for social cognition. This ToMI-2 result is not surprising given KF's diagnosis of autism spectrum disorder, but what will be interesting is an in-depth examination of his theory of mind strengths and challenges in light of developmental expectations for his age. Here, KF's results are presented in a bar graph by subscale. This is an example of a bar graph that a user would receive as part of the results when the ToMI-2 is administered electronically. The numbers at the top of each bar represent his mean score within that subscale. Remember, the composite score is calculated using only the early, basic, and advanced subscales. If we look only at the raw subscale data, we see that his early theory of mind subscale mean was 11.1, basic subscale mean was 9.6, and advanced theory of mind subscale mean was 4.1. These are all scores below the 10th percentile in relation to typical age norms. But compared to these areas, there may be relative strength in the area of mental state term comprehension, which has a subscale mean of 16.4, which was associated with the 9th percentile. This strength area fits with what we know about KF. He is a highly verbal individual and has academic strengths in the domain of literacy. So compared to the areas of emotion recognition and pragmatics, there may be a relative strength in the area of mental states term comprehension. So even though KF received a standard score of 27.8 in this subscale, which is in the 9th percentile, inspection of the subscale shows that this low score is driven by 2 items in particular. But for the rest of the items, KF shows great strength with scores that are age typical. Moving to the table for treatment planning allows us to examine normative and raw score information jointly. Examination of the first 2 rows of the table for treatment planning repeats the finding that KF received scores in the area of mental state term comprehension for the items think, need, and want that were age typical. The same was true for the area of desire psychology, that is, knowing that people are happy when they get what they want, which is an early emerging skill in typical development. Acknowledgement of these strength areas is important as treatment could capitalize on these developments. For KF, who loves reading, writing, and drawing, we are thinking that he could benefit from story or narrative-based treatments that could make use of mental state terms to make explicit the links from knowing, wanting, thinking, and feeling to doing, acting, and behaving, which is developmentally more advanced. The third row of the table for treatment planning only a portion of which is seen here, reveals challenges in that KF's scores for these items are low for his age. That is, they are at least one standard deviation below the mean. Remembering our maxims of right to left and light to dark, we should first examine the items in the rightmost column. Items in this cell show areas that are relative deficits when KF is compared to typically developing children, but relative strengths when these areas are compared to other areas of functioning within KF's theory of mind profile. This is because the caregiver is indicating that this capacity is probably, although not definitely, present. As is explained in the table for treatment planning, these areas of theory of mind development could be a priority for intervention, especially when the area is seen as foundational to current and later success, or the goal of intervention is to establish competency in this area more consistently across time or context. For KF, intervention could focus first on either early, light blue, or basic, medium blue, theory of mind skills. For KF, we believe that it may be useful to ensure consistency of the early skills of basic affect recognition, that is, happy, sad, and mad, and discrimination of basic emotions. These can be viewed as foundational skills, so there is good rationale for their selection as a target. In addition, we believe that it is appropriate to target some basic skills for which we have confidence that KF has some understanding. This includes the area of mental state terms comprehension, here with specific regard to understanding the word no. Recall that KF has strength in mental state terms comprehension, but there were 2 items on that subscale for which his scores were low. These were the mental state terms know and believe. As noted above, mental state term knowledge could be pivotal to success using story-based narratives with KF, and so reliable competency in these areas provides a needed foundation for intervention. Of course, our ultimate goal is to further scaffold and advance KF's social cognitive understanding. This can be shown through demonstrations of success or growth in the areas just described. Revisiting the table for treatment planning, it appears that KF has challenges in the following areas, and raw scores for these items is between 7 and 13, which indicates caregiver uncertainty with regard to whether these competencies are present. For KF, these areas included a few early skills which are considered foundational to later, more advanced theory of mind and is considered of cosmic importance to social cognitive development. These areas are intentionality, sharing attention, that is, initiating and responding, and social referencing. Focusing on a few basic level items would also be appropriate to further KF's nascent emotion recognition and mental state terms comprehension skills. As such, treatment focusing on basic negative emotions, such as disgust, fear, and anger, the aforementioned mental state term comprehension, believe, and targets are natural extensions of KF's initial treatment plan. Similarly, advancement to mental state terms comprehension to include the lexical terms believe is appropriate, but need not be limited to this item. More specifically, we believe that it is appropriate to also support KF's mastery of more advanced mental state terms that are not included as items on the ToMI-2. These are the mental state terms remember and forget. Of course, items that appear in the far left column are important. Provided that gains in earlier developing skills are achieved, these would then become viable treatment goals, and the importance of continued monitoring of theory of mind development cannot be understated. As would be expected, we find that changes in theory of mind occur over time. This happens as a result of maturation, effective intervention, and accrued social experience. Recall, one notable strength of the ToMI-2 is its appropriate use as a repeated measure. For this reason, and in light of the potential, indeed probability, of theory of mind change over time, we encourage professionals to monitor theory of mind development as appropriate, as this constitutes a tenet of good clinical practice. With that, we conclude this presentation on the use and interpretation of the ToMI-2. Thank you for taking the time to listen to this tutorial. We hope you found it helpful in answering any questions you might have about the ToMI-2. For more information, please see the following sources and be sure to visit us online at theoryofmindinventory.com. Thank you.